Voyager 1's journey is one of the most remarkable stories in space exploration. Launched by NASA in 1977, Voyager 1 was originally designed for a 5-year mission to study the outer planets, but its journey has extended for over 4 decades, making it the first human-made object to reach interstellar space. Here is a complete, detailed background of Voyager 1, from its inception to its groundbreaking achievements. In the early 1970s, following the success of the Apollo missions, NASA shifted its focus toward exploring the outer solar system. There was growing scientific interest in the gas giants, Jupiter, Saturn, Uranus, and Neptune, and their moons, rings, and unique magnetic environments. In 1964, NASA discovered that a rare alignment of the outer planets would occur in the late 1970s, allowing a spacecraft to use gravity assists to travel from one planet to the next in a single mission. This alignment, occurring once every 176 years, offered a grand tour of the outer planets, significantly reducing travel time and fuel needs. Program planning and design. NASA decided to capitalize on this alignment with 2 probes, initially intended as part of the Mariner program, then developed as a separate mission, the Voyager program. The 2 spacecraft, Voyager 1 and Voyager 2, were designed and built by NASA's Jet Propulsion Laboratory, or JPL. Primary objectives: Jupiter and Saturn flybys. Voyager 1's primary mission was to study Jupiter and Saturn, focusing on their atmospheres, magnetic fields, moons, and ring systems. Its objectives included imaging the planets, analyzing their magnetic and radiation environments, and studying the structure and composition of their rings. Extended mission. While initially focused on these 2 planets, the mission planners designed Voyager 1 to survive long enough to travel beyond Saturn and explore the outer boundary of the Sun's influence. Spacecraft design and technology. Structure and size. Voyager 1 is approximately 3.66 meters or 12 feet high with a 3.7 meter or 12-foot high-gain antenna for Earth communication. It weighed about 722 kilograms or 1,592 pounds at launch. Power supply. The spacecraft is powered by 3 radioisotope thermoelectric generators, also known as RTGs, that convert the heat from the radioactive decay of plutonium-238 into electricity, providing an initial power output of about 470 watts. Communications. Voyager 1's communication system relies on a high-gain antenna, enabling it to send data to Earth across billions of miles. It uses NASA's Deep Space Network, with round-trip communication times taking over 21 hours due to its distance. Scientific instruments. Voyager 1 was equipped with 10 scientific instruments. 1. Imaging Science Subsystem, or ISS, high-resolution cameras to capture detailed images. 2. Infrared Interferometer Spectrometer, or IRIS, to analyze thermal emissions and study atmospheric composition. 3. Ultraviolet Spectrometer, or UVS, to study ultraviolet emissions and atmospheric particles. 4. Magnetometer, or MAG, to measure magnetic fields around the planets. 5. Plasma Science Experiment, or PSE, to analyze solar wind and plasma environments. 6. Cosmic Ray System, or CRS, to study cosmic rays. 7. Low Energy Charged Particle Instrument, or LECP, to measure charged particles in the environment. 8. Photopolarimeter Subsystem, or PPS, to study light scattering in planetary rings. 9. Dust Detector Subsystem, or DDS, to study interplanetary and planetary dust particles. And 10. Plasma Wave System, or PWS, to measure radio waves in planetary magnetospheres. Launch date. Voyager 1 was launched on September 5, 1977 from Cape Canaveral, Florida, aboard a Titan IIIe rocket, following the launch of its twin, Voyager 2. Trajectory and speed. Voyager 1 used a gravity assist from Jupiter to increase its speed and alter its trajectory, setting it on a faster course than Voyager 2 toward Saturn. Jupiter encounter 1979. Arrival. Voyager 1 reached its closest approach to Jupiter on March 5, 1979. Discoveries at Jupiter. Volcanism on Io. Voyager 1 discovered active volcanoes on Jupiter's moon Io, the first known example of geological activity beyond Earth. Jupiter's atmosphere. Voyager 1's images revealed details of Jupiter's Great Red Spot, a massive storm system, and provided insights into Jupiter's turbulent, banded atmosphere. Magnetosphere and radiation belts. The probe mapped Jupiter's powerful magnetic field and radiation belts, which were much stronger than expected. Moons and rings. Voyager 1 studied Jupiter's many moons and found that it had a faint ring system, making Jupiter the second planet in the solar system known to have rings. Saturn encounter 1980. Arrival. Voyager 1 reached Saturn on November 12, 1980. Discoveries at Saturn. Ring structure. The probe's images revealed intricate details in Saturn's rings, including structures like the spokes and gaps, some created by the gravitational effects of nearby moons. Titan's atmosphere. Voyager 1 discovered that Saturn's moon Titan had a dense, nitrogen-rich atmosphere, filled with methane and organic compounds. Titan's thick clouds prevented a detailed view of its surface, but the findings suggested that Titan could support complex chemistry, sparking interest in further exploration. Magnetic field. Voyager 1 measured Saturn's magnetic field, contributing to a deeper understanding of gas giants' magnetic environments. After its Saturn encounter, Voyager 1's trajectory directed it out of the plane of the solar system. NASA then focused on sending Voyager 1 toward interstellar space. Crossing the heliopause. Heliopause. Crossing, 2012. On August 25, 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind from the Sun meets the interstellar medium. Heliopause crossing, 2012. On August 25, 2012, Voyager 1 became the first human-made object to cross the heliopause, the boundary where the solar wind from the Sun meets the interstellar medium. This transition marked Voyager 1's entry into interstellar space. Ongoing interstellar exploration. Interstellar data collection. Since entering interstellar space, Voyager 1 has been studying cosmic rays, plasma density, and magnetic fields in the interstellar medium. Interstellar data collection. Since entering interstellar space, Voyager 1 has been studying cosmic rays, plasma density, and magnetic fields in the interstellar medium. Its data have provided new insights into the nature of interstellar space and the influence of the Sun's heliosphere. Message to the cosmos. Voyager 1 carries a golden record, a gold-plated copper disc with sounds, music, images, and greetings in 55 languages, intended as a message to any extraterrestrial civilization that might encounter it. Contents of the record. Curated by a team led by Carl Sagan, the record features greetings in 55 languages and a message of peace from then U.S. President Jimmy Carter. Music from various cultures, including works by Bach, Beethoven, traditional Peruvian and Japanese music, and rock and roll. Sounds of nature and images of Earth, its people, and various forms of life. Pale Blue Dot Image, 1990. As part of its legacy, Voyager 1 captured the famous pale blue dot image of Earth from a distance of 3.7 billion miles. The image, requested by Carl Sagan, symbolized Earth's fragility in the vast cosmos. Scientific contributions. Voyager 1 has provided unprecedented data on the outer planets and interstellar space, shaping our understanding of the solar system and beyond. It inspired future missions, including Galileo, Cassini, and New Horizons. Distance and communication. Voyager 1 is now over 14 billion miles, over 23 billion kilometers, from Earth, and communication via NASA's Deep Space Network takes over 21 hours. Power management. As its power decreases, NASA has gradually shut down non-essential systems. The mission team is carefully managing power to keep Voyager 1's core instruments operating until approximately 2025, when power is expected to run out. Conclusion. Voyager 1 stands as a monumental achievement in human space exploration, representing the human spirit's drive to explore beyond known boundaries. Its long journey has revolutionized our knowledge of the solar system, and as it travels deeper into interstellar space, it continues to be a symbol of our quest for discovery.